Hello, in this video tutorial we're going to take a look at Skills Practice 14.2, Wave Interference. Please remember to pause or rewind the video as necessary. Let's begin. Interference occurs when two or more waves are at the same location at the same time. For instance, wind may create tiny ripples on top of larger waves in the ocean. The superposition principle states that the total vibration at any point is the sum of the vibrations produced by the individual waves. In other words, we add the amplitudes. Constructive interference is when waves combine to make a larger wave. Destructive interference is when waves combine to make a smaller or completely cancel the waves. Noise-canceling headphones work to produce a sound that perfectly cancels the sound in the room. This worksheet will allow you to find the sum of two waves with different wavelengths and amplitudes. The table below and continued on the next page lists the coordinate points of the two waves. The first step is use the coordinate points on the table to graph on the last page what the wave 1 and wave 2 should look like individually. And then we're going to connect them with a smooth curve. Okay, so notice on the x-axis is the first column here. And if you go on the next page, it goes all the way through 32. So if we look on the very last one, we can see that there are a total of 32 blocks all the way across on the x-axis. So what we're going to do is we're going to plot them one at a time. We're simply going to go each block like this, and we're going to plot them one block at a time. So at 0, we're going to plot 0. Zero, 0. At 1, we're going to plot 0.8, and so on and so forth. So what we're going to do, let's see here. Let's see, no, the second one would be about 0.8, which is almost to 1. So this would be 1, 2, 3, 4 units high, -1, -2, -3, -4 units high. Okay, so what I'm going to help you do is, what I want you to do is kind of go back and forth and plot the wave. Okay, pause the video, and then when you're done, go ahead and resume the video to see if it matches what you have. Okay, so if you continued plotting at block number 2 on the x-axis, you have a height of the wave at 1.5. So I would make another dot 1.5 units high. At block 3, it's 2.2. So I'm going to go a little bit greater than 2. At block 4, I'm at 2.8, which is almost to 3. At block 5, I'm at 3.3, which is a little bit higher than 3. At block 6, I'm at 3.7, which is almost to 4. At block 7, I'm 3.9, which is really almost to 4. And at block 8, I'm exactly at 4. Block 9, I'm back down to 3.9. Block 10, I'm back down to 3.7. And I start creating symmetry, right? How I was going up is exactly how I'm going down. So that means at block number 11, I'm back to 3.3. And block 12, I'm back to 2.8. Block 13, I'm back to 2.2. Block 14, I'm back to 1.5. Block 15, I'm back to 0.8. And block 16, I'm back to 0. Again, I'm getting all of this from this table right here. Specifically, I'm focusing on the first row. Okay, the first column, excuse me. Okay, now I continue. I'm on block 17 now. So block 17, I am at negative 0.8. So negative 0.8 would be down this way. Here's negative 1, so negative 0.8 is almost to there. Then I'm at block number 18, so I'm at negative 1.5. And then block 19, I'm at negative 2.2. Block 20, I'm at negative 2.8, almost to negative 3 would be here. Then I'm at block 21, which would be at negative 3.3. And then block 22, I'm at negative 3.7. Block 23, I'm at negative 3.9. And then finally, block 24, I'm at negative 4, which is down here. To finish off this thing, I'm at block 29, I'm at negative 3.9. That would be block 25, excuse me. Block 26, I'm at negative 3.7. Block 27, I'm at negative 3.3 again. Block 28, I'm at negative 2.8. Okay, block 29, I'm at negative 2.2. Block 30, I'm at negative 1.5. Block 31, I'm at negative 0.8. And block 32, I am back to 0. So if I draw a nice smooth curve that goes through those points, you can see it would look just like that. Okay, and I've got a wave that has a wavelength of 32 units long, right? Because that's one complete cycle right there. Okay, now let's graph wave 2. So in order to graph wave 2, I am now focused on this column here, which is actually easier because it's oscillating between 0, 2, 0, back to negative 2, 0, 2, 0, back to negative 2, right? It's very predictable. So this one's going to be easier to do. I'm going to go so this is going to be 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, negative 4. So I'm going to go, I'll do this in a different color. I'll do this in red. Okay, so I'm going to go 0, I'm at that block, and then at block 1, I'm at 2. So 0, 2, and then at block 2, I'm back to 0. Okay, and then at block 3, I'm at negative 2, which is down here. At block 4, I'm back at 0. And this process literally repeats all the way. 2, 0, negative 2, 0. 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 And then 2, 0, negative 2, 0. Now, what would that look like? I'm going to miniaturize this so I can get a better picture of this. But essentially, what this would look like is a nice smooth curve that goes up, down, and just keeps repeating. Up, down, up, down, up, down, up, down, up, down, up, down, up again. There we go. Try to draw it as best of a smooth curve as you possibly can. Don't draw a jagged, sharp, sawtooth looking like wave. Just nice, as best of a smooth curve as you can. Now here, you should notice that one wavelength is 4 units long. Okay, in other words, this would be one cycle. Just like this is one cycle, that is one cycle. So a wavelength is only 4 units long. in the case of wave number 2. Okay, so if we go back to some of our questions, what is the amplitude? We can answer some questions on the way. What is the amplitude of wave 1? What is the amplitude of wave 2? Now we know the wavelength of wave 1 is 32 blocks. It's 32 units because it is literally the entire unit across. The wavelength of wave 2 is only 4 units. Okay, but let's go back and look at the amplitude. The amplitude of wave 1 is going to be 4 units high. The amplitude of wave 2 is going to be 2 units high. Okay, how many wavelengths did wave 1 did we draw? Well, we drew 1 wavelength. How many wavelengths did we draw in number 2? Well, if you can look, there are a total of 1, 2, 3, 4, 5, 6, 7, 8 complete cycles. Therefore, there's 8 wavelengths. Okay. Now, part 8, we're going to use the superposition principle to find the wave that results from the interference of these 2 waves. To do this, you're simply going to add the heights of wave 1 and wave 2 at each point to get this right here, which is wave 3. It's going to be the height of wave 1 plus wave 2. Notice how it's done already. 0 plus 0 equals 0. 0.8 plus 2 is 2.8. 1.5 plus 0 is 1.5. 2.2 plus a negative 2 means you're subtracting. So 2.2 minus 2 is 0.2. Okay? I want you to right now pause the video and try and figure out the remaining wave 3. That's height of wave 1 plus height of wave 2. So fill out the last column here. Okay, and then go ahead and resume the video and see how you did. Okay, so the next one, of course, would be 2.8 plus 0, which would be 2.8. And then we're going to go 3.3 plus 2 is 5.3. 3.7 plus 0 is 3.7. Okay, then we're going to go 3.9 plus a negative 2 means minus 2, and that's 1.9. 4 plus 0 is 4. 3.9 plus 2 would be 5.9. 3.0 plus 3.7 plus 0 is 3.7. 3.3 plus a negative 2, or 3.3 minus 2, would be 1.3. 2.8 plus 0 is 2.8. 2.2 plus 2.2 plus 2 is 4.2. Okay, so we're over here now. 1.5 plus 0 is 1.5. 0.8 minus 2 is negative 1.2. 0 plus 0 is 0. Negative 0.8 plus 2. Negative 0.8 plus 2 is going to be 1.2. Negative 1.5 plus 0 is negative 1.5. Negative 2.2 minus 2, or plus a negative 2, is negative 4.2. Negative 2.8 plus 0 is negative 2.8. Negative 3.3 plus 2, right? That's negative 1.3. Negative 3.7 plus 0 is negative 3.7. Okay, and then negative 3.9 minus 2, that's going to be negative 5.9. Negative 4 plus 0 is negative 4. Negative 3.9 plus 2 is negative 1.9. Negative 3.7 plus 0 is negative 3.7. Okay, and then negative 3.3 minus 2 will be negative 5.3. Negative 2.8 plus 0 is negative 2.8. Negative 2.2 plus 2 would be negative 0.2. Negative 1.5 plus 0 is negative 1.5. Negative 0.8 minus 2 would be negative 2.8. And then finally, 0 plus 0 would be 0. So what we're going to be doing now is we're going to be graphing all these values here. Okay, so let's right now again pause the video, graph the height of those for each block. Remember, there's 32 blocks along the way. Okay, the one hint I'll give you is that you now have 0, 1, 2, 3, 4, 5, 6 going up, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 going down. Okay, so if we begin graphing this, okay, I'll do this one in black. We're going to have a first point at 0, 0. Okay, so at block 0, we have a height of 0. At block 1, we have a height of 2.8. So we're going to go up to about almost 3, like that. And then we have at block 2, we have a height of 1.5. So we're back down here. Okay, and at block 3, we have a height of 0.2, which is going to be down really close to 0, but not quite there yet. Okay, and then we're back up to 2.8. Okay, so block 4, we're back up to 2.8. Like that. Okay, now block 5, we're up to 5.3. It should be a little beyond 5, just like that. At block 6, we're at 3.7. Should be about right here. At block 7, we're at 1.9, which is a little less than 2. About right here. At block 8, we're at 4, so that's easy. Okay, at block 9, we're at almost 6. We're at 5.9. We're way up here. Okay, at block 10, we're at 3.7. It's right about there. At block 11, we're at 1.3, which is right about down here. At block 12, we're at 2.8, which is right there below 3. At block 13, we're at 4.2. Should be right there. At block 14, we're at 1.5, which is back down here. At block 15, we're at negative 1.2. So now here's negative 1. Negative 1.2 is a little lower than that, so we're down here. Okay. Now at block 16, we're back to 0 again. Okay, we're halfway there. Block 17, we're back up to 1.2. Block 18, we're back down to negative 1.5. That'd be about right here. Okay, block 19, we're down to negative 4.2. So negative 4.2 would be about right there. At block 20, we're down to negative 2.8. Roughly about there. Okay. So now we're at block 21. Block 21, we're down to about negative 1.3. Block 22, we're down to negative 3.7. At block 23, we're down to negative 5.9, almost negative 6. At block 24, we're down to negative 4. At block 25, we're at negative 1.9. At block 26, we're at negative 3.7. At block 27, we're at negative 5.3. About down here. At block 28, we're at negative 2.8. At block 29, we're at negative 0.2. About right here. Almost at 0. At block 30, we're at negative 1.5. At block 31, we're at negative 2.8, almost negative 3. Okay, and at block 32, we're back to 0. So what is this one going to look like? Well, it's going to look like this. Up, down, 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 up. And so here's what you end up with. Notice you have the often repeating nature of the second wave. But notice you also have the longer wavelength associated with the first wave. So you have this combination of the two, hence the interference pattern that's developed, because interference refers to the combination of the two. Okay, so part 8, we did that. We added up the first one, okay? We finished graphing this new wave, and we connected the points to make a smooth curve, right? And describe the wave that happened. Well, this wave is a combination of wave 1 and wave 2. Right? It's long like wave 1, but repeats often like wave 2. It is a combination of the two. Okay? I hope you found this tutorial helpful. Again, please remember to pause or rewind as necessary.